Hi, hello, and welcome back. Even as we continue with probability distributions. So today, last time we focused on the previous video, we focused on more specifically on probability distribution, which follows a discrete case. But in this case, or in this video, we're going to focus on the probability distribution, which focuses on the continuous case. So now, how does a continuous case in this case look like, or what are the characteristics of this probability distribution which follows a continuous case? So remember, we simply said that a random variable can be discrete and a random variable can be continuous. It can be discrete if it takes up countable values. So when we talked about discrete, we simply say that x is taking up countable values. That's what we simply said. It's taking up integers, basically 0, 1, 2, 3, what you are able to count. That's what x as the random variable takes on. But when it comes to the continuous case, we are simply saying that this time around the x is basically taking up values on a certain given interval. I believe we even gave various examples. For example, if you're taking maybe the time maybe students are arriving in a class for statistics. So they will basically, if maybe statistics is happening at 7 hours, could be maybe in 7 hours sharp, others are coming at 7:01, others are coming at 7:02, others are coming at 7:10. So we discovered that for the whole class to be filled up, there is a range of interval which you are trying to follow, maybe from 7 hours to maybe 7:30. That is a period of time which the students are able to come on time. Yeah. So how do we define this continuous case? We're simply saying that in a case where x is a continuous variable, so in a case where x is a continuous variable, we are being told that, or maybe a continuous random variable. So this is abbreviated as CRV. Just like we were talking about discrete case, something which is taking up a discrete is abbreviated as DRV, discrete random variable. But a random variable which is a continuous random variable, it is abbreviated as CRV. Then we're simply saying that then the corresponding probability distribution is called the probability density function. Now, I have to be able to understand the difference when we are dealing with a discrete case and when we are dealing with a continuous case. When we are talking about discrete case, the probability distribution is called the PMF, which is probability mass function. So the DRV follows the PMF, which is the probability mass function. But the CRV, this one corresponds to a distribution which is called the probability density function, which is called the PDF. So that is the understanding you're supposed to be able to take note of. So PDF in this case is basically denoted by f of x. This is a small letter f of x, like that. So any function which is given as f of x with a small letter f, where x in this case is following a continuous case, is basically just called the probability density function, which is called the PDF. So now, when it comes to DRV, discrete random variable, simply say that it follows a PMF, which is probability mass function, where the probability mass function was denoted by P of X. I'm sure if you can recall from the previous video which we simply mentioned. PMF is equal to the P of X, probabilities of X. But in this case, the probability density function PDF is basically denoted as F of X. So I believe by this time you're supposed to be able to tell the differences between both cases, the continuous case and the discrete case. So now we simply said under the discrete case, the PMF can be written as a graph, can be written as a list of probabilities, or it can be written as a function, can be written as a list of probabilities, and it can also be written in form of a table, a formula, and the like, or a histogram. So you can be taught to say form a histogram from the, just as we did from the previous example. You can be taught to form a table or to form a formula depending on the case you are dealing with. The same is happening even on continuous case. So the PDF can be represented by, so simply saying that the PDF can be represented by, we can represent the PDF using a curve, and the probabilities can be given under the area under that curve. So we are simply saying that when it comes to the probability density function, the PDF can be represented using a curve. And then this curve, when it is drawn, we are simply saying that the probabilities can be given by the area under the curve. So basically, if let's say for example, a curve, maybe we can talk about is something like that. So the area under this curve are the probabilities we can talk about. So from here to there, there's a certain interval which x can take up of, because we're talking about x variables here. Maybe we're talking about from 0 maybe up to 10. From 0 up to 10 here, we are able to find the area under this curve. The area under this curve is basically found by the integration of the function which is forming this curve. So the area under this curve, the probabilities can be given by the area under this curve. You can maybe talk about the probability of maybe getting less than 10. It means that it is the whole area from 0 to 10. Probability of maybe getting less than 9 is from 0 to 9. So the area under this curve will be able to give you the probabilities. That's the interpretation we're trying to have here. Yeah. So if that is the case, being the PDF, we are simply saying that if the probabilities are given by the area under the curve, we are simply saying that we can calculate this probability as P over bracket A less than X less than or equal to B to be the probability that X is between A and B. This is just basically the probability that X is in between X is in between A and B, where you're talking about the area. So this is the probability that X falls under or falls between, let me use between, falls between A and B. So if you want to find the probability of X which is falling between A and B, this is just basically the integral from A to B of f of x dx. Remember, what is f of x? F of x is basically the what? The probability density function. So you want to find the probability of any given interval for x, then you are just basically integrating the function which is the PDF at those limits A to B. We are okay? So now we have to understand that if we have a PDF, now we have this formula where we're simply saying that the probability can be given as a less than x or x less than b, which is just basically x being following the values a and b, is the integral from a to b of f of x dx. So what are we simply saying here? If f of x is a valid PDF, so the will be cases whereby we thought say confirm if f of x is a valid PDF. So we have two information which you are supposed to be able to understand when f of x is a valid PDF. So f of x can only be a valid PDF if, number one, if f of x is greater than or equal to 0. Then we are simply saying that f of x there can be a valid PDF using the first condition for all values of x. Remember, this is basically just talking about the probabilities of x. So if f of x is greater than or equal to 0, then the PDF is valid. We cannot have the probability to be less than 0. And then the other condition we're supposed to be able to understand here is that the probability of negative infinity less than x less than positive infinity is basically just the integral from negative infinity to positive infinity of f of x dx. So this integral, for it to be a valid PDF, this integral using these two bounds, we are simply saying this should be equal to a 1. So f of x is only a valid PDF if the given intervals for x there, or maybe the given intervals where x is basically taking, should, when we're integrating that function between those two intervals, the integration should be equal to a 1. And if this is the case, then you can conclude that f of x is a valid PDF in this case. So now, from this information, we are supposed to be able to understand that this is an information which says that f of x to be a valid PDF. So no matter how your question can be phrased, and they tell you to say confirm if f of x is a valid PDF, this is how you'll be able to confirm is f of x greater than or equal to 0, and is the integral between those two bounds, f of x, being equal to a 1. And then we are simply saying that if x is indeed a continuous random variable, if x is indeed a continuous random variable, we are simply saying that then we have the probability of x equal to a is basically the probability that x takes on a specific value equal to a. That's an interpretation I'm supposed to be able to have there. So if x is a continuous random variable, probability of x equal to a is basically the probability that x takes on a specific value equal to a. So if you'll be able to have a PDF, you'll be able just to replace maybe the values of a and the like, and be able to solve something. So now, this is the case we are having. We have the second case here, where we are simply saying that if this time around we are finding the probability of x where a is less than or equal to x and x is less than or equal to b, this probability is the same probability when you are finding the probability of a less than or equal to x and less than b. I'm sure you're able to take note of the inequality symbols there. This one is less than or equal to x and x is less than or equal to b, with the same happening whereby the same probability you're going to have when you have probability of a less than or equal to x and x is less than b. And it's the same probability you can have when you have probability of a less than x or less than or equal to b. And it's the same probability you can have when you have probability of a less than x less than b. So all those, this probability is the same probability as this one and the same probability as that one, despite you having any kind of inequalities is less than or equal to or greater than or equal to, as long as it's falling under that interval, the probability is the same according to the continuous random variable x. So as long as x is a continuous random variable, we are supposed to be able to detect those rules. Is it a valid PDF? Then f of x should be greater than or equal to 0, or the integral between those two bounds of f of x should be equal to a 0. Okay, so we have an example written for us there. What is the example saying? I'll read it and we're going to follow through. So the question says, a lecturer of statistics tries to arrive at his office between 7:20 hours and 7:30 hours each morning. Because of some events beyond his control, the actual time between 7 hours and 7:40 and the lecturer of statistics tries to arrive at his office between 7:20 and 7:30 hours each morning because of some events beyond his control. The actual time is between 7 hours and 7:40 and is described by the probability density function PDF equals to that. So this is a situation, just as we simply said, x can be discrete or x can follow a continuous case. It follows a continuous case when we're talking about the values of x are falling under a certain interval. They are not countable numbers, but basically certain interval. For example, in this case, there's a possibility that you can reach at 7:21, 7:22, 7:23, up to as long as it's in between that interval. So in this case, we are being told that the actual time between, actually this is supposed to be 710. The actual time is between 7:10 and 7:40 and is described by this probability density function, where we're being told that f of x is equals to negative of x minus 40 over 450 if 10 is less than or equal to x and x is less than or equal to 40. Basically, that is the interval of x, what x can take up. It can take up 10, meaning 7:10. It can take up 11, meaning 7:11. It can take up 12, meaning 7:12, up to until we reach 7:40. That is the normal interval given in this PDF. So all the probabilities of the time which it can arrive at are falling under that interval. That's what we're being told in this question. So now, it means that for you to find the probability in this case, the probability can only exist between that interval 10 to 40. The probability will be 0 when it is elsewhere, meaning that the probability can be 0 outside the bounds. For example, if I want to find the probability of this person arriving at 7:50, what is the probability of the person arriving at 7:50? The probability is 0 because the interval given is 10 to what? To 40. What is the probability of this person arriving at 7 hours sharp? The probability is 0 because the interval is 10 to what? To 40. That is why even there is an emphasis here to say the PDF is this if 10 is less than x and x is less than 40 and d it is 0 elsewhere. So how do I write this information? So if you are rewriting your PDF f of x can be equal to negative x minus 40 over 450 with the interval 10 less than or equal to x and x less than or equal to 40. So this is the PDF and we're simply saying it is 0 elsewhere. That's the interpretation for that. So now, what is the first question saying? The second question is simply saying verify that f of x is a valid PDF. I'm just confirming or talking about valid PDF. A PDF can only be valid if and only if a PDF is valid if the integral from negative infinity to positive infinity of f of x dx should be equal to what? A 1. Then you can conclude that the PDF is valid. So now we are going to use this integration. So negative infinity to positive infinity, that's basically representing the intervals given. So we integrate the f of x on the intervals given. So let me just erase this top part, since we've already written our PDF there. So erasing this top part, I'm going to have the integral using this, since PDF is valid if the integral of negative infinity to positive infinity of f of x dx is equals to 1. So this means that according to the question we are simply saying it's the integral from the lower bound, which is 10, and the upper bound, which is 40, of f of x. What is f of x? F of x is negative x minus 40 over 450 dx. So if we integrate this, the solution should be equal to 1. Then if it is equal to 1, you can conclude that it is a valid PDF. Well, okay? So now let's begin our integration. So I'm sure you can still remember your integration rules. That's what we're doing here. So now, if I'm integrating here, I have to understand that this can still be written as 10 over 40 negative 1 over 450. 10 to 40 negative 1 over 450 x minus 40. I'm sure we understand. Negative 1 divided by 450 is more like the one which is multiplied with x minus 40 dx to be equal to a 1. So that when I'm integrating here, since I'm integrating with respect to x, this guy can be treated as a constant, brought outside, and I'm going to have negative 1 over 450, the integral of 10 to 40 of x minus 40 dx. So integrating, I'm sure you're still remembering the rules of integration. Integrating with respect to x for this one, this will be x squared over 2. Integrating this one, this will be what? 40x. And the bounds and the limit is running from 10 to 40. And we have negative 1 over 450 as our constant value, which is outside. So now, what does this limit tell us? We are replacing in there and we find the difference. So what is going to happen? Replacing with the 40 there, I'm going to have negative 1 over 450, open brackets, 40 over 2, this is squared, minus 40, 40. So the solution for this, subtract and I replace the lower bound, which is a 10, which will be 10 squared over 2 minus 40, 10. You close there. We okay? So replacing everything, what am I going to have? So 40 squared divided by 2 minus that. So this whole guy, I believe if you use your calculator very well, you'll be able to find that 40 squared blah 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 blah. I think that is supposed to be, with our calculator, this is something like I think negative 800, if I'm not mistaken. You can confirm. You can confirm. And then this side, remember this is minus in between, but my brackets. So minus this. So minus the outcome for this when we replace a 10, and the outcome when we replace a 10 is negative 350. And outside we still have the constant negative 1 over 450. And then doing the same, punching in the operation in the brackets, that is a negative and negative, this will be a plus. So this is basically just 350 minus 800, this will be negative 450, and there's a negative 100 and 450 this side. So this is negative and this is negative, automatically it will be a positive. This is 450 over 1. So times, there's a times here multiplying negative 1 over 450 multiplied by negative 450 over 1. It means that this will just give me positive 450 over 450, which is basically equal to a 1. And the 1 has come out because what we simply said that if you integrate under those two limits, the integration should be equal to 1, then it means that you verified that the PDF is valid. So the integral between a and b, or the integral between 10 to 40, should be equal to a 1. And after that is done, then you can conclude that it is a valid PDF. Okay? Okay, so now we're answering now the second part of the question, which is instructing us to find the CDF. Remember, when we were talking about descriptive case, we talked about the concept where we can find the CMF. The CMF is found from the PMF. Remember, when X is following a descriptive case, then for DRV we have the PMF. From the PMF we can come up with the CMF, which is called the cumulative mass function. Where we were obtaining this, you can follow the previous video how we were obtaining the CMF. We were just adding up the successive probabilities there. So if PMF was equal to probability of X, then CMF was equal to the probability of X less than X, something like that. That's what we're looking at. So now that was the case. So now the same is happening here even under the PDF. So if we have the PDF, probability density function, so continuous random variable case will have the PDF, which is basically given as f of x. So now the same is happening here when we want to find the CDF. The CDF is the cumulative density function, which is basically the probability of x less than x as well, but using the approach of the f of x, which is the PDF. This was the probability of x less than x in the PMF. For the CMF, it's coming from the PMF. The CDF is coming from the PDF. So PMF is in a discrete random variable case, probability mass function, where we can derive the CMF, which is the cumulative mass function. When it is continuous random variable, we have the PDF, where we can have the f of x. From the f of x, we are deriving the CDF there, where we are simply saying find the probability of x being less than the x there. So now we have to understand that if f of x is the PDF, then the cumulative this CDF is denoted by the capital letter F of x. This is a small letter f of x as my PDF, but the CDF would be the capital F of x, distinguishing it from the PDF. PDF is the one which is forming the CDF. So what is this capital letter f of x? The capital letter f of x is just basically the probability that x is less than x, like that. So now remember what we simply said when we are finding these values. Probability of x less than x, it means that, remember, when it comes to the probability in this case, the lower bound we have here, it is a 10. So we are starting to do everything starting from 10, because the probability is 0 elsewhere. We can only start counting our probability starting from 10 based on the given interval. So we start from 10, we'll go way up to a 40, we don't know. But when it comes to the CDF, we don't know where we are ending from, because it's more like the successful addition of the probabilities. So we do not know where we are ending at. No wonder we're simply saying x will be less than x. We can end maybe at 30, we can end maybe at 20, we don't know. So x can take up with something which is greater than what? Something which is greater than 10. So if I'm looking for the probability of x less than x, this is just basically the integral from 10 being the lower bound to the higher bound. X is less than x. It is x which I'm looking for, this one. It is the one which is on the upper bound, not the 40, but x is representing any value in between from 10 to what? To 40. So if this question says find the CDF, you're just integrating the PDF from the lower bound to the x. So we're integrating from the lower bound to the x. Integrating what? Integrating f of y dy. So now from the PDF is given in terms of x, but when you're replacing it in here, we're replacing wherever there is x, we're replacing with y and integrate it with respect to y at the bounds or at the limits 10 to x. So this is basically integral from 10 to x of negative y minus 40 over 450 dy. Yeah, so we are integrating that one. So the same thing, this is, we're trying to integrate with respect to y. So 1 over negative 1 over 450 is still a constant. It's going to come outside. I'm going to have negative 1 over 450 outside. The integral from 10 to x of y minus 40 dy. Integrating these ones, I'm going to have negative 1 over 450. Integrating it, I'm going to have y squared over 2 minus 40y. And the limit from 10 to x. Replacing the limits, what am I going to have? I'm going to have negative 1 over 450, open brackets. Where there is y, I'm replacing the x, which is the upper bound, x squared over 2 minus 40x. This solution, subtract, when you replace with the 10, I'm going to have 10 squared over 2 minus 10. Something like this. That's what I'm going to have. The next thing I can now continue from there, it is just basically me now trying to simplify things from there. So simplifying things, what are you going to have? So when you simplify everything there, we're now going to have something like this side. I'm going to still have negative 1 over 450, open brackets, to still be x squared over 2 minus 40x. Then when you evaluate with the 10 here, it will be minus 350. Something of such. So that we can now have this negative and this negative will be positive. I'm going to have negative 450, open bracket, x squared over 2 minus 4x plus 350. Something of such. So now, this function which has been formed is the capital letter F of x, which is called the what? The CDF function. The cumulative density function for the PDF. The cumulative density function for the PDF. We're okay? So now, remember we were looking for, this was the PDF, which was the second part. There is the third question which instructed us to find the probability that the lecturer arrives between 7:20 and 7:30. What is the probability that the lecturer will arrive What is the probability that the lecturer now will arrive between 7:20 and 7:30? That's what we are looking for now. So now, when you are finding the probability of the lecturer arriving, see here, finding the probability that the lecturer will arrive at 720 to 730. So now, there are two ways of handling this one. You can use the CDF function or you can still use the PDF function. So when you are using the CDF, this is just basically when you are finding the probability of 720 to 730, this is just basically capital letter F of 20 minus capital letter F of 30, because x is 20 to 30, like that. So you are using the CDF which you found here to say the probability from 720 to 730 will be just x taking up 20 to 30. So capital letter F of x function is this one. So you replace your 20 on the x, the answer, you replace the 30 on the x, and you subtract the two expressions. That is what is going to give you the probability that this lecture can arrive in that given interval. So what am I going to have? We can do this, or you can just basically find the integration from 20 to 30 of the PDF. There's a difference between CDF and PDF. The CDF, it is this one which we've newly found, but the PDF, it is the one which was in the question. So the PDF, if I want to use the PDF to solve for this one, it's the integral from 20 to 30 of that PDF. But if I want to solve the using the CDF, it is basically this function replaces the 20 where there is x and replaces the 30 where there is x and find the 2. No minute, eh? So now when I use this one, I'm going to have the value or the probability to be equal to negative 1 over 450, open bracket. I replace the 20 first. This will be 20 squared over 2 minus 40. This is 40x. So to be 40, 20 plus 350. So the solution for this, subtract when you replace a 30 in there, which is 30 squared over 2 minus 40, 30 plus 350. So this minus that, what are we going to have? I'm sure you can work with your calculators wherever you are and be able to punch in. So basically, what am I going to have? Sorry, it's the bigger value minus the smaller value. It's supposed to be f of 30 minus f of 20. Sorry. So it means that it's 30 and here it's supposed to be 20. So here it's the 30, but here it's supposed to be 20, and the like. So it's the upper limit minus the lower limit. Upper limit minus the lower limit. So when you do the bad manners of everything, what are we going to have? We're going to have negative 4 over 50. And the summation, everything in the brackets, you punch in. What are you going to have? You will have something like this minus that, I believe. It will be something like negative 150, and negative and negative is positive. This is 150 over 450, and this will be equal to 1 over 3. So the probability that this lecturer is going to arrive between 720 and 730 is basically 1 over 3. How is this found? It's found by using either the CDF or you use a PDF. So if I use a CDF, I'm basically replacing the x with the upper limit. The value we subtract with that expression with the lower limit. So 30 will be the upper limit and 20 will be the lower limit. So f of 30 minus f of 20 is how we've come up with the 1 over 3. If you do not want to use the CDF, you can use the PDF, where you can just integrate from 20 to 30 of this CDF, the PDF, and you'll still be able to find the value for 1 over 3. So now the task I want you to be able to use is find the probability using the CDF, integrate from the limit from 20 to 30 of f of x. What is f of x? F of x is the PDF given in the question. So integrate and find the value. Is it equal to 1 over 3? And that will be the one of the question I'll be able to tell that you've gone through this video. Thank you very much and have a blessed day.